Hello, let's take a look at the product rule with differentiation. Given here is a function g of x, and this function is equal to 2x multiplied with sine x. If we want to find the derivative, as they are asking in part A, we have to use the product rule. So I'm going to say the derivative of g of x is equal to, now of course you can use the formula if you want, or you can just try to memorize what is the best way to do it, but I'm always telling myself, okay, so I'm going to say the first 2x multiplied with the derivative of the second. The derivative of sine of x is cosine of x, plus, and then I'm going to find the derivative of the first 2 multiplied with the second sine of x. I can simplify this if I wanted to without the brackets. 2 cosine of x plus 2 sine of x. So every time that I find the derivative of a function, this derivative is the gradient of the function at a point. So for part B, when they say find the gradient of the graph of g at x is equal to pi, so we have the gradient, and now we can find the gradient at a certain point. In other words, they tell us where x is equal to pi. So I'm going to substitute this in here. So I'm going to say the derivative, but instead of x, I want to find it at pi. So this will become 2 pi. So this pi is in the place of x, multiplied with cosine of pi plus 2 of sine at pi. And then I have to remember, so cosine at pi, if I have my cosine graph here, so remember my cosine graph looks something like this. So the period of a cosine function is 2 pi. So at pi, my cosine graph is going to be -1. And my sine graph looks something like this. And of course the period of my sine graph is also 2 pi. So here, this is the point pi on my sine graph. So sine of pi is equal to 0. So I'm going to say this becomes -1, so it becomes -2 of pi plus 2 multiplied with 0, which is 0. So the gradient of the curve at the point x is equal to pi becomes -2 pi. Here is another example of the product rule. So they tell us let f of x be equal to e to the power of x multiplied with cosine of x. So when I want to find the derivative for this function, so the first derivative is going to be, I'm going to take my first e to the x multiplied with the derivative of cosine of x, which becomes minus sine of x, plus, and then I'm going to say the derivative of the first, but the derivative of e to the x stays the same. So therefore e to the x multiplied with cosine of x. So if I wanted to, I could factor this out in e to the power of x. It doesn't matter. Cosine of x minus sine of x. But alternatively, I could have left my answer like this as well. Then they tell us to find the gradient of the normal. So we will look at what the word normal means with the gradient. But first, let's go and plug in pi for x. So I'm going to say the first derivative at the point of pi. So this becomes e to the pi. And now cosine of x at point pi. So cosine of pi minus sine of pi. And e to the pi, I know that cosine of pi is -1. And sine at pi is 0. So it becomes -1 minus 0, and therefore this will become -e to the pi. But this is the gradient of the tangent. So the gradient of the normal means that I have to find the negative reciprocal. In other words, if my gradient is -e to the pi, I have to multiply it, or with the negative, so it will become positive, and I have to find the reciprocal, which means e to the pi. So this will be the gradient of the normal to the curve. Now let's take a look at the quotient rule. So there are part A and part B. They say use the quotient rule to show that this is the first derivative of my function g of x. So I'm going to say the first derivative of g of x. So for the quotient rule, I normally say the following. So I always start with my denominator. So it's going to be x squared, and I'm going to square my denominator. It's as simple as that. We can simplify this later. Then I'm going to say it is my bottom, my denominator, so this is x squared, multiply with the derivative of my numerator, the derivative of the top. The derivative of the natural log of x becomes 1 over x minus the top, or my numerator, in this case it is natural log of x, multiplied with the derivative of my denominator, which is 2x. I will just include brackets here. So if I want to simplify this, it becomes x to the fourth. Now x squared multiplied with 1 over x will just leave me with x, and minus 2x times the natural log of x. So this is my first derivative. But let's try to simplify it a little bit more. So I can factor out an x here. So if I factor out an x, then I am left with 1 minus 2 natural log of x, x cubed. Now this is in its simplest form, which is good because later if we want to substitute in some values, it will be easier. For part B, they say the graph of G has a maximum point at A. Find the x-coordinate of A. For any function at a maximum or a minimum point, it means that the gradient of the curve or the tangent of the gradient of the tangent is equal to 0. So that means where is my first derivative equal to 0? So what I can do is I can go and say the following. I can say, let me just get my pen here. I can say 1 minus 2 natural log of x over x cubed is equal to 0. Where is the first derivative equal to 0? Because the gradient at a maximum or a minimum point is equal to 0. Then I can try to simplify it in terms of x. So I'm going to multiply both sides with x cubed, and then I am left with the following. If I take the 1 and the negative 2 to the other side, then I'm left with the natural log of x is equal to a half. Now, of course, the natural log is the same as log base e of x. So when I want to write this in exponential form, x is equal to e to the power of a half. This is the x-coordinate of my maximum or minimum.